See, in this problem, there is a disk of say radius r. So initially it is rotating about its axis with an angular velocity omega naught or omega 0, and it is kept on a horizontal surface. There is ground, that is g is acting downward. So the coefficient of friction between ground and the disk is equal to mu. After what time the disk will stop? Now, in this problem, I will look from bottom actually. From bottom, I will look at the surface. This is the face or the bottom face of the disk. Bottom face. That means the face lying on ground. So it has got radius r. So it is rotating with this angular speed omega naught in the beginning, and gradually this angular speed will decrease. So we will take here thin ring elements. So a ring element will have a radius r, and obviously thickness of the ring is dr. So now the total normal force is equal to mg, because this m is the mass of the disk. So now, as the disk rotates, there is a frictional force, and hence there is a torque due to the frictional force. Okay, so the torque of frictional forces on the ring is equal to torque is so the force will be mu mg by pi r square. This is the pressure, that means the force per unit area on the face of the disk, multiplied by area of the ring will be 2 pi r dr. That's quite obvious, because if you open up the ring, so this will be 2 pi r, and that this will be dr. So 2 pi r dr is fine. So this is actually the force. See, obviously the net force will be 0 because it forms the circular line, right? But for the torque, the torques will add up. So this is the force, which is mu mg by pi r square 2 pi r dr. This is force multiplied by r, distance from the axis O. This O is the axis. So that's the torque. Now the net torque. So the net torque will be tau equal to, just integrate this. So this pi and pi will cancel. So it will be 2 mg mu by capital R square into small r square dr. So integrate from 0 to r. So there you get so 2 mg mu by r square into r cube by 3. So that is 2 by 3 2 by 3 mu mg by 2 by 3 mu mgr. That's it. Yeah, so that's the torque. So 2 by 3 mu mgr. So now this angular acceleration or angular retardation in this case, so it's equal to 2/3 mu mgr divided by, for the ring, it's half mr square. Moment of inertia is half mr square. For the disk, sorry, not the ring, it's a disk. So after dividing, we get this 4 by 3 mu g by r. So now it will stop after time t. So let it stop after time t. So now, we'll apply this. So omega is omega naught. Here adds, it is decreasing, so minus alpha t. So therefore final angular speed is 0. So omega naught minus alpha t. So this t is omega naught by alpha. So if you put this omega naught by alpha, so that's it. That's the time. here let us put the time. So omega naught by alpha, that is 4 mu g by 3r.